Hi everybody, welcome to another video in Calculus 1, section 5.4, working with integrals. So before we actually go to something more complicated integration, I will just go over this section, just cover some little bit of here and there that we left off from the integration. Right, first, taking advantage of an even and odd will help us in the integration by a lot. Right, definition: an even function is a function where we say f of negative x is the same as f of x. An odd function is f of negative x is equal to f of negative f of x. So that's nice and all, but also important. The graph of even function is symmetric about the y-axis. The graph of an odd function is symmetric about the origin. Now, of course, we study even and odd and even and odd functions, coarse algebra, trigonometry, recalculus, all of that. So now we know what kind of functions are even or odd. So x to an even power will be even. Absolute value of x also even. A constant function is even. What else? How about trig function? Out of those functions, which one is odd, which one is even? So let's just give you some example. If we have cosine of x, for instance, this is symmetric on the y-axis, so this is even. And of course, reciprocal 1 over cosine of x is secant, is also even. Right. Now, odd function. An odd function will be x to the odd power, or we have an index odd root of x, or 1 over x is also. And in terms of trig function, sine, reciprocal of sine is cosecant, tangent, reciprocal of tangent is cotangent. So those functions are even, those functions are odd. And we have the important things here. Linear combination of even function are even, linear combination of odd function are odd. The mixture of both of them is neither. Right, so I will use those properties to actually do that rather than use definition, which might take a little bit more work. If we use this properties, we'll get the answer right away. For example, x to the 4th, that one is even, right? X squared is even. 3 is a constant, is also even. Now, these single terms, all of them are even, so we say the whole function are even. Now, take that to the higher level. I will write this characterize an even function by a positive. Even function is associated by a positive. In that case, we have all the positive combined together. It's going to be positive. So therefore, it is still even. Of course, if we use a definition, this is what we write with. This is the function. So first thing we do is we find f of negative x. So we put negative x in for x. Negative x to the 4th power is even. Negative after that again. And since this is equal to the function itself, this is even. Yeah, if we want to use definition, that's how we do it. Next example, sine is odd. 3x, x to the first power is odd. So we have an odd combined with an odd. By combine, I mean plus or minus. It's not multiply or divide. It's just like when we take derivative or integrate. For all integral, we can take individual terms and then we combine them. Yeah, so combine, by combine I mean just plus or minus. So odd and odd combined together is odd. If we want to use a definition, this is how we do it. G of negative x. I will put in negative x in for x. Sine of negative x, because sine is odd, it is sine, negative sine of x. Negative, negative, that's plus 3x. Of course, this is not equal to the function, so it is not even. But if we factor out the negative, we have the same as the function. So this is equal to negative of the function. So that's why this is odd. So if we want to use definition, this is how we do it. But in shorthand notation, an odd function is associated with a negative sign. Combine negative and the negative. We're not talking about multiply, right? If we add or subtract two negative numbers, it's going to be negative, so it's still odd. Right, next one. Absolute values even. X is odd, tangent is odd. Since we have the mixture of at least one odd and one even, this one is neither. Next, this one is x is going to be odd, x squared is even, 5 is even. So what do we have here? Kind of difficult, right? So that's why I use the plus or minus to associate it. A plus associated to an even function, a positive sign associated to an even function, a negative sign associated to an odd function. X squared is even associated with the plus sign, minus 5 is also a plus sign. Yeah, I just combine them. Plus or minus, it's just a combination. So I'm not going to say multiply, or I will not put anything into it. So that's what we have. So on the top is a negative, the bottom we have a positive and a negative, a positive and a positive. Of course, the positive and positive is positive. Now when we divide, this is negative. So that's why this one is odd. Yeah. Next. X is odd, cosine is even. So if we associate the x here is odd, so associate with the minus sign, cosine x, that is even. Negative times positive is negative, so this one is also odd. Next one, x squared is even. I use the plus sign. And one constant is even. The bottom sine x, sine is odd. A plus and a plus is the plus. Divide by positive, divide by negative is negative. So this one is also odd. Of course, you can always use the definition, but think about this. We can have multiply or divide. But if it is plus or minus, I'm just going to write n instead of plus or minus. A plus and a plus is a plus. A minus and a minus is a minus. A plus and a minus, that is neither. Right, so it's not thing to see that what is an odd and even function. Of course, we can use right like that, or we can use a definition like this. Right. Now, how did that help us in the integral? Now, important things that we write earlier. Even function is symmetric about the y-axis. Odd function symmetric about the origin. So if this is an even function symmetric on the y-axis, so mirror image on the y-axis, so in that case this area on the left hand side is the same as the area on the right hand side. So when it is even, instead of go from negative a to a, we can just go to double half of it. Now we can only use this theorem if it is from negative a to a, meaning that the limit have to be symmetric or opposite. So here we have opposite limit, meaning it go from a negative number to a positive number of the same magnitude. If that is the case, if it is even, we're just going to double from 0 to that number. Now if it is odd, it's symmetric about the origin. In that case, we will have something above, something below, right? If both of them above, it cannot be that, because it is symmetric about the origin. If the point above, up symmetric has to be below, and likewise. So something above, something below, and those two areas are the same. So if we have an odd function with opposite limits, the integral is going to be equal to 0. By the way, of course the function have to be integrable function. Even more than that, the function has to be defined when we use this. If it's undefined, yeah, that could be something complicated. So we're dealing with only the function that are defined. So with symmetry help us a lot in this case. So say, how did that work? Let's look at the sample here. So first we look at this. This is even, that is odd, right? Now let's split this into individual terms, because together an odd function and an even function is neither. So in that case we have to group all the even function together and all the odd function together. Now the reason we can do this is we have the opposite limits. If we don't have the opposite limits, don't even bother to look at the even and odd function. It's not going to help. It only helps if we have the opposite limits. Now using symmetry with the opposite limit, to execute, this one is odd and an odd because symmetric on the origin. This one equal to 0, so that equal to 0. Help us a lot. Now this one is even. If it is even, we're going to double the half. So instead of go from a negative to a positive number, we're going to go from 2 just do half of it and then multiply by 2. And we say, how does that help? Just by a little. Right, we have a 2 integral of 2x to the 4th. X to the 4th integral is x to the 5th over 5. Going from 0 to 2. Right, the 2 in front, just multiply to it. So that's what we have. So we have 4. The 5 at the bottom is 1/5. X to the 5th. Going from 0 to 2. Now, 4 times 1/5, 4/5. X to the 5th. Even though it is even, they don't cancel out. I only double the halves. Evaluate this is a lot easier than evaluate with the negative. We're just going to put in the positive numbers here. Upper limit, and then the lower limit is 0. Usually it is easy to evaluate when x equal to 0. So in that case, this one go to 0, and we just need to do this 2 to the 5th 2 to the 5th is 32 times 4, 128 over 5. Yeah. We know that this is odd function symmetric limit, so that go to 0. That's simplifying a lot. Of course, if we want to check the math, we can always at least get the number and see if it works. 2x to the 4th minus 3x cubed is that 128 over 5? It is. So it's good. Yeah. So using odd and even, that certainly helps. But once again, only works if the limits are symmetric. Right. Next, cosine is even, sine is odd. So the mixture of them, so we have to separate them so we can actually use this term. Right, we split them in 2. Dx. So the limit are symmetric, and the function is defined. If the function inside is undefined, yeah, we cannot say anything, cannot use this here. So sine, this function is odd, the limit is opposite to each other, this goes to 0. This function is even, so it's going to be double the half. Double the half, meaning go from 0 to pi over 2. Right, integral cosine is a positive sign, and there's a 2 in front of it. Right, go from 0 to pi over 2. Right, put in the upper limit. Subtract where we put in the lower limit. Sine of 0 is 0, sine pi over 2 is 1, so this is just 2. Right, and of course we can check the answer. Yeah, it's good. Yeah, so it's nice and all, but notice that the limits have to be opposite in order to do this. Right, another small application of integral, definite integral, is the average value function. So the average value function of a function from a closed interval a to b is going to give us that. So what actually is limit average values of the function? So average values of the function denoted by f bar so the average values of the function is, think about this, when we talk about the integral, that is the area under the curve. So let's say we have the function like this. That area is equal to, now, and I said, what if I want to find a rectangle with the same width? What would be the height so that this area of the rectangle is the same area as that definite integral? Well, whatever that rectangle is, it will have the average as the height. So in that case, we will average values of the function is the average height. So that average height multiplied by the width will give us the area, which is the same as the integral of a to b. So the area of rectangle is the same as the average height times the width of the interval. Right. So, and the theorem say this is by the intermediate value theorem. It says that if the function is continuous, there will be a point where there will be a point that gives us the average height. So if there's the function is continuous, there will be the average height, and there will be a values that give us that average height. Right. Let's look at the example here. A hiking trail has the elevation given by that, and f the measure in feet above the sea level. Of course that. Now, what is the average elevation of the trail? Of course, if we go up and down, it's difficult to find the average. The way to find the average is that we're just going to use the average values of the function. So, in a sense, if we have three numbers and we find the average of them, we add all of them up, divide by how many numbers we have. So in this case, 3 plus 4 plus 7 divided by 3. The problem here is the average value of the function. The function defined from 0 to something, let's say 0 to 5 in this case. We have infinitely many values. So we cannot just add all of them up. We have a bunch of values. So in that case, this will sum up all the values and then divide by how many we have here. So in a sense, that's like the average. Add all of them up, divide by how many numbers we have. Now the sum, the integral, we add all of them up, divide by the width of the interval, which is how many we have. So in a sense, that gives us the average values of the function. So if we want to find the average values of that function, we're just going to have 1, because the function defined from 0 to 5, we just going to do this. So we have 1/5 integral from 0 to 5, and then the function. Right, I'm just going to use the calculator on this one. Fraction 1/5, and then we integrate from 0 to 5. The function is 60x cubed minus 650 x squared plus 1200 x plus 4500 dx. Alright, and I have about 3,958. This is in feet. Yeah, so the average height is about that much. So if we see that if this is the function, the average height is about that much. So now, if we want to, when we calculate the area under the curve, this area will be the same as this area from 0 to 5. With the average values function. So the area under the curve will be the same as the area of this rectangle, because that has the average height, which represents the whole function. Right, I'm just going to use the calculator to get the values, because we spent some time dealing with the integral already. Right, next, I'll find the point on the interval from 0 to 1 at which this equal to the average values from 0 to 1. So first we will find the average values of the function from 0 to 1 from 0 to 1, so the width is going to be 1 minus 0. Or from 0 to 1 to x, 1 minus x dx. Yeah, let's do this one by hand, because 1 divided by 1, which is 1. So we just have to integral. I will multiply it out to x minus 2x squared. Right. Let's integrate. The integral of x is x squared over 2. Later on, we just write x squared. Integral of x squared is x cubed over 3. 1 from 0 to 1. 2 and 2 cancel out. That is x squared. 2 on the top, 3 at the bottom. That is 2/3 of x cubed. 1 from 0 to 1. Put in 1 in for x. That is a cube. Subtract, put in 0 in for x. Zero times anything, so that is 0. 1 minus 2/3. 1 minus 2/3 is 1 over 3. So just 1 over 3. So yeah, the average height is 1 over 3. Now, according to that theorem, there will be a point on the function where the function equal to the average values. So the function is 2x, 1 minus x. There will be a point that is equal to the average value, so meaning that equal to 1 over 3, and there will be a solution for that. So multiply this out. 2x minus 2x squared equal minus 1/3. Multiply everything by 3. 6x minus 6x squared equal to 1. Let's arrange them. Move everything to that side. 6x squared to that side minus 6x plus 1 equal to 0. And there should be a solution for that. Right. And then we just solve for x. And whatever x is, that should be between 0 and 1. So I use quadratic formulas here. Negative 6 plus or minus negative 6 squared minus 4 AC over 2A. Negative 6, so that's 6. Do a plus first. Square root negative 6 squared minus 4 times 6 times 1, that is 24 over 12. So that is about 0.78. Which is about here. Or of course we can also have the solution when it is subtract, so we go back, subtract, and that gives us 0.211. Of course both of them between both of them between 0 and 1, and that could satisfy the theorem. Whatever the point the point has to be between the interval that gives us the average height. So it is in between, so we're good. Right, so that's the average value function. Now we just go back to this and just pick up a few things about integral. So use geometry to evaluate this one. So what is the graph of square root of 9 minus x squared look like? By the way, it is an even function. Graph. That looks like a circle. By the way, it's missing some point here because of the calculator, they do some rounding error. So think about this. We're talking about a function y equal to square root of 9 minus x squared, right? This is the function. F of x equal to square root of 9 minus x squared, or y equal to. Let's square both sides. Usually when we square both sides, we do need to check the answer. But square will undo the square root. And we move the x squared to the other side. And what's this? This is equation of a circle, radius at 3, radius equal to 3, center at the origin. So this is a circle, radius equal to 3, and the center is at 0, 0. So if we go on the graph, it is a circle. But because it is only positive, so it's only have the upper half of it, of the circle. So the semicircle. And this one will get the area under the semicircle. So the area of half of a disk. So because of that, we just said this is going to be 1/2 of the area of the whole circle. Which is 1/2. Area of the circle is pi r squared. The radius is 3. So this equal to 1/2 times 9 pi. Or we have 9 over 2 pi. Right. If we do this by hand, it's going to be in calculus 2 and very complicated problem. It takes quite a little bit of work. Right, math from -3 to 3, the integral square root of 9 minus x squared. And we have that. Yeah, even the calculator takes some time to do. Now, is that equal to 9 over 2 pi? 9 over 2 is 4.5. Right. Now you see that the calculator will calculate that has some error. There's some different here. The first few digits are the same, but the calculator will have some error. So the calculator only estimate. The way the calculator get the answer is just like what we do earlier. They divide into a bunch of rectangles and add them up, or maybe a little more complex scheme, but the calculator after all can only estimate the answer. So that's why the estimation may be a little bit off. We know the exact answer is 4.5 pi. Right. Having said that, if I just want to define the same function, if I want to go from 0 to 3, in that case I only have 1/4 of a circle. In that case I have 1/4 pi 3 squared, which is 9 over 4 pi. Yeah. So if we go from 0 to that number, that is going to be a fourth of a circle. By the way, we have the symmetric limits. The function is even, so going to be twice of this, right? Yeah. If it's odd, it would be nice, but it's even. So now next, evaluate the definite integral. Well, we won't be able to do this until the next section. If we have to find the integral, that look complicated. But we can take advantage of the even and odd because we do have the symmetric limit. So when we have the symmetric limit, trying to see if the function is even or odd, that might save us a lot of calculation. Now let's say if this is the function, and of course we have the top is odd, characterized by the negative sign, the bottom a plus and a plus. So together, negative divided by positive is negative. So this is odd. Let's just prove it. Using f of negative x. I put negative x in for x. That gives me 5x squared, 5x over x squared plus 3. Now, I can manufacture an extra negative if I negate the top. In which case, I have the same as the original function with an extra negative. Because of that, it is odd. Yeah, so if we use a definition to prove, that's how we do it. Now, if it is odd and the symmetric limits, so this is going to be 0, right? Right. It's equal 0 because we have the function is odd and the limit are symmetric. This is equal to 0. The limits are opposite, so it's going to be 0. By the way, if this problem is negative 4 over 4 negative 5x over x cubed minus 3, this is completely different things because when x equal to some values, let's say change that to 1, for example, to make things easier, x squared minus 1. When x equal to 1, this function is undefined. Whatever we use here will not apply to that. So be careful when we say the limits are opposite and the function is odd, it is equal to 0. Yes, but make sure the function inside have to be defined as well. Because if it's not defined, we don't know what is the height and we don't know what will be the area. That will be tricky. Yeah. So, but in this case, because x squared plus 3 is not going to be 0, we don't divide by 0. It is defined. And opposite limits, an odd function, the integral will be equal to 0. So that saves us a lot of time. If we want to do this, that will be in the next section. Right. So, yeah, we just want to pick some nice tool in this section, namely take advantage of even and odd, but only for opposite limits, and the function should be defined in order to use that. So kind of limited application, but when it works, it's extremely simple. Of course, and the average values function. Alright, but that's all I want to cover in this section. As always, thank you for watching and see you in another video in Calculus 1.